Hey guys, this is Vasforine here, and my old high school just posted Rimmel Meet 2 2020. So what I decided to do was the only thing I could do at this point, which is just to mock the test and just to do it under actual conditions, real time. I will have a timer next to me, and basically what's going to happen is just going to be 5 rounds, 3 problems each, certain category for each round that I'll mentioned beforehand. I do not know anything about these problems ahead of time, so we're just gonna get into it. I'm gonna put my timer on my phone here. Um, you're just gonna have to believe me when I say I'm putting it for 10 minutes. But then there's a team at the end, which I'll probably give myself 20 minutes just so I get like 4 minutes per problem. I think that's fair. Because usually you do it as a team, but I'm doing it solo. So yeah, we're just gonna get into it. It's on the second tab. Or the first tab. No, that's my calc book. But I have not done this at all. I've never seen it. Right when I open it, we're gonna go. So this first round is arithmetic number theory and matrices. 3, 2, 1, go. The sale ad. Okay. Ooh, interesting. Okay. Oh my God, what the heck? The sale ad read, buy 3 tires at the regular price, get the fourth tire for 3. Oh, okay, 3x. So each tire's x, 3x plus 3, 240, 3x, 237, x equals. Oh, get the fourth one for $3? Um, 237 divided by 3, so that's what? 721, subtract 2, you get 7, 9. Oh, by the way, I'll put this up on the YouTube, all my notes, just so you can see it. So the first one's $79. Matrices. Ooh, interesting. Okay. So you can just distribute out 4x, 4y, 4z, -4, um, equals 2y plus 8, 2z plus 2x, -2x plus 10, -2x plus 10, and 2 minus 2x, 2 minus 2x. Oh, by the way, I'm counting Algebra II miscellaneous as my actual score. Oh, actually, I don't know yet. I'll just do that at the end. Hold on. Okay, so wait, 2 minus 2x is -4, so 2 minus 2x, -4, 2x equals 6, x is 3. So then we could say that 2z, this is 2x, so that's 6. This is -4. So -2x plus 10, -6 plus 10 is 4, so z equals 1. Z is 1. And then 4x, so 4x is 12, equals 2y plus 8. So 2y is 4, y equals 2. And we want x plus y minus 2z, so 3 plus 2 minus 2 times z, which is 3. So 3. Number 3, range of numbers from 1 to 9. Each number is, is this a magic square? The product of the entries in the first row is 10. Product of the entries in the second row. Oh my God. What? Oh my God. This is prime factorization time. So this is like a magic square kind of, but the product, usually that means the sum's equal. So wait, first row is 12. So A, B, C is 12. Product of the entries in the second row is 112. D, E, F, 112. Product in the first column is 216. A, D, G, 216. And the product of the entries in the second, so B, E, H, is 12. Oh my God. Okay, so wait, B, E, H is 1, 2, or 6, or 2, 3. No, it has to be. No, it could be 1, 4, or 1, 3, 4, or a permutation. But product in the first row is 12. Product in the second row is 112. Wait, so what's 112? We have to find the prime factorization of that. 2 and 56, 2 and 28, 2 and 14, 2 and 7. So it's 2 to the 4 times 7. So 7 times 2 cubed times 2. That's the only possibility. for them to be single. So 7 times 8 times 2. That's the 112 is the second row. So DEF is here. BEH is 126. DEF is 782. So that means the only one they have in wait, yeah, DEF is 112. BEH is also 12. So that means they have to share something in common. The only one they share is 2, so E is 2. So it's something, comma 2, comma something. So then B and H, B is either 1 or 6, but the product in the first row is 1. So wait, product in the entries in the first row is 12. But wait, ABC is 12, but you can't use 12 again. So it's got to be 4, 3, and 1. 4, 3, and 1, but this is either 7 or 8, right? Oh, shoot. This is tricky. Unless it actually is 1, 2, and 6 somehow. No, it's not. It's got to be 4. But then you don't get 12. DEF. Unless this isn't the only way. Because you can't do 7, 4, and 4. Oh my god. This is tricky. Product of the entries in the second row is product in the first column is 216, which is 666. So that's 2, 3, 2, 3, 2, 3. So we could get, you can't use 6 because, yeah, you can get 8, 9, and 3. 8, 9, and 3 is going to be AD and G. So ADG is 8, 9, 3. I'm gonna have to guess if I don't know. ADG. This is so dumb. But DEF is 12. So that means you have to have a multiple of. So wait, D is 3. D is 3. Has to be 3. Because it's the only divisor of 12 of the 3. 8, 9, and 3. Wait, so that's 3. So the product in the first column is 216. So this is going to be 8 and 9, but I don't know which one it's going to be. But the product in the first row is 12. That's not possible. Oh my god, what? 8? It's got to be 6, 2, and something. 1. Product in the second row is 1. Because 216, yeah, 8 times 9 times 3. But then DEF is 112. Oh, 3 is A. A is 3. Oh, okay. That makes sense. And then the column is 8, 9, 3, but the product in the second row is 112. So we either have 8 or 9, but 112 has to be divisible by 8. So this is 8, this is 9. Holy god. Okay. So 3, 8, 9. Product in the first row is 12. So this has got to be 4 and 1. But product in the second column is 12. So this is probably 1 and 4, I bet. And then product in the first row, or no, second row is 112. But 112 is, we already have 8, so 2 and 7. So this is 2 and 7. And then second column is 12. So this is 6, and then this one has to be 5, right? Yeah. Okay, so AEI is 325. 325. That has to be it. Because product in the first row is 12, second row is 112, first column is 216. Yeah, 72 times 3. And then, yeah, that works. Perfect. AEI is 325. No way I just did that out of nowhere. That is so funny. Let's just check the first one. I mean, yeah. 3 tires at the regular price, so 3x. 4 tire for $3 equals 240. At the sale price. And yeah, you just want one. So it's 79. That makes sense. Yeah, I think I got the second one fine. And the third? Yeah, I'm done. Easy. We'll actually stop the timer right now. And done. So this is round 1. And I'll just put the answers down. 3, 2, 5. Alright. Algebra 1. Again, I wouldn't be doing this round. Ready, set, go. Oh, okay. If 5 times a number is 2, what is 100 times the reciprocal? So 100 over x. So x is 2/5. 100 divided by 2/5. So that's 500 halves. 250. Very easy. I did that in 20 seconds. X squared plus y squared is less than or equal to 3. X and y are both integers. Again, integers is not positive necessarily. So wait, we have... Oh. It's just a circle with radius √3. That's all it is. But you can't have 2 plus 1. You have to have 3 plus 0. So you have 3 comma 0, 0 comma 3. Oh, wait, no, that's root. Wait. Oh, it's an inequality. It's not equal to. Okay. 1, 1, 1, negative 1, negative 1, 1, negative 1, negative 1, 0, 0, 0, comma 1, 0, comma negative 1, 1 comma 0, 1 comma, or negative 1 comma 0. Wait. So it's 9. It's really a circle of radius √3, and then you just find the, wait. 1, 2. So √3 is like, I don't know, 1.7, I think it is. So it's really just this. I'm just drawing a circle. So yeah, 0, 0, 1, 0. So we have 1, 2, 3, 4, 5. Negative 1, 0. Negative 1, negative 1 also works. It's 9. Yeah, I think 9. Solve for x. They're just all in the form of something over 9. Because 11, it's really, it's basically, oh, I don't know how this works exactly, but it's like 11x equals 99, or no, 99x equals 11. Because it's really 100, but then you have to subtract it. Because it's 11 over 100, but you subtract the 1, if you know what I mean. So then it's 1/9. Okay, so it's 1/9 x minus 4/9 x plus 5/9 times 3x equals 7/9 minus 1/4 times 1/9 x. Ooh, okay. So it's just a linear system or equation. So 1/9 x minus 4/9 x plus 15/9 x equals 7/9 minus 1/36 x. Okay, we can simplify the left. Negative 3. So that's 12/9 x equals 7/9 minus 1/36 x. But we can really simplify this to 4/3 x equals 7/9 minus 1/36 x. So 4/3 x, so it's really just finding a common denominator. Multiply by 12, so 48 over 36x. Equals times 4 times 4, 28/36 minus 1/36x. 49/36x equals 28 over 36. X equals 28 over 36 times 36 over 49. X equals 28 over 49 divided by 7. X equals 4/7. That's what I'm getting, 4/7. Okay, that should be the answer. Yeah, so 250, that's definitely number one. X squared plus y squared is less than or equal to 3. Yeah, so 0, 0, anything with 0 is fine, that's not. Yeah, so 1 comma 1, 1 negative 1, negative 1, 1, negative 1, negative 1, 0, 0, 0, 1, 0, negative 1, 1, 0. That's just a bash. You can't have it equal 3, you can have it equal 2, and having it equal 2 you can find in 4 different ways. You have 2 different for the first, 2 different for the second, you have the 1 and the negative 1, so it's just 2 times 2. Then you have 0, 0, which is obvious, and then you have ones where it could just be 1. So that's it. And then the third one is just knowing what, or that really, the 0.11 repeating 0.44, it's just 1/9. God, they love solve for x. And I think, I'm just gonna check the time, 4 minutes, 39 seconds, we're fine. 1/9 x minus 4/9 x equals 5/9 3x, good. 7/9 minus 1/4 times 1/9 x. Why don't we just sub it in and see if it actually works? 1/9 times 4/7, 4/63. 4/9 times 4/7, 16/63. 15/9 times 4/7, 60/63. So this becomes negative 12/63. Because we're subtracting, add it to this to get 48/63. This has to equal the right-hand side. So 7/9 minus 1/36 of x, which is 4/7. 7/9 minus 163, but this is really 48/63. Good, 4/7, done. All right. Okay, we did it at 324. Okay, I'm just gonna write my answers on this sheet. Round 2, 1, 2, and 3. 250, 9, and 4/7. Okay, Geo. Geo's gonna be an interesting one. I always love a good Geo round. Ready, set, go. Ooh, okay. Tommy's thinking of an angle. He tells Townsend that the supplement of the... What? They always use these. He tells Townsend that the measure of the supplement, so 180 minus x, is 33 degrees... 30... Wasn't this a freaking... This was on one of the past meets, I think. 33 less than 4 times measure of the complement. So 4 times the measure of the complement, 4 times 90 minus x, minus 33. So 180 minus x equals 360 minus 4x minus 33. 180 minus x equals 327 minus 4x. 3x equals 157. No. 147. X equals 49. The measure of the supplement would be 131. 33 degrees less than 4 times the measure of the complement. So the complement is, or 4 times the measure of the complement would be 41. 41 times 4, 164. Yeah, exactly. It is. Because it's 131. Good. Okay, number 2. Use the diagram below. A triangle has exterior measures. That's not bad. Because exterior sums to 360, so it's just the sum of the two exteriors plus the interior minus 180. Okay, wait. So 3c minus 15 plus 2c plus 180 minus, and then the c plus 5 equals 360. So 5c minus 15 plus 180 minus c minus 5 is 360. 4c, 165, 160 plus 160 is 360. 4c is equal to 200, c equals 50. I just want to make sure this actually works. I'm actually going to draw it out. So 3c minus 15 would be 150 minus 15, so 135. Interior would be c plus 5, so 55. And that one would be 2c, which is 100. Therefore, the interior is 80. And the other interior is going to be 45. So 80 plus 100. Yep, perfect. It's 50. For trapezoid HJK, SNT are the midpoints. ST is 72. The height is 11 more than half of HJ. Determine the area. That's not hard. This is not hard at all. Because SNT are midpoints, so really, if the midpoint is 72 and you have 86 as the larger one, the smaller one is just going to be 86. Well, no, it's the distance from 72 to 86, but you do that under. So it's 86 minus 72, which is 14. 72 minus 14 is 58. Because the two legs have, when you take the average of the small and the large legs, you're going to get the middle, the median, or whatever you want to call it. And then the height is 11 more than half of HJ. HJ is 58. So the 11 more than half, so 29 plus 11 is 40. So the area is 86 plus 58 times height over 2. Oh my god, this is going to be pretty ugly. So 144 times 20, 288, so 2,880. Done. 6 minutes to spare. I just did this in 4 minutes. This is what I was like at the actual competition. Like, I did rounds in usually 3 minutes for most of the time, unless I was really stuck. Yeah, AGKL, S&T are the midpoints. ST is 70. Yeah, because ST has to be the average of HJ and LK. So 72, 86, yeah, 14, so it's 58, good. And then 11 more than half, so half of 58 is 29. 29 plus 11 is 40. So 40 then becomes the height. And then base 1 plus base 2 times height over 2. So it's really the sum of the two bases, so 144 plus, or no, that's 144 times the height over 2, but the height is 40, so it's really 144 times 20, or 2,880. Yeah, I just want to make sure. Tell me, yeah, 100, yeah, it's 49, because the supplement is 131, and that's 33 degrees less than 4 times the complement, but the complement is 40, no, the complement is 41, so 4 times that is going to be 164, and 164 minus 33 is 131, and that's the supplement of 49. So we're good there, and the 50 is good. So we're done. Done. I'm pretty sure I got a 6 on that one. So 49, 50, 2,880. Okay, round 4. Watch there be this ugly system for the third one, I swear. 3, 2, 1, and go. Ooh! Wow, this is low quality. What is the greatest in number is that even a 3-pointer? What is the greatest integer contained in the solution set? Oh, I don't like inequalities. Negative 3x plus 6 minus x squared plus 3x is less than negative x squared minus 2x minus 8. So cancel out the negative x squareds. Cancel out the 3x's. So 6 is less than negative 2x minus 8. 14 is less than negative 2x, so x, well, no, wait. Negative 7 is greater than x, so the greatest is, wait, what? No. Wait. It's negative 8, right? Because anything less is just going to be lower, so it's -8. Number 2, solve for x, and it's a really easy log. So log 8x is equal to 12 log 2. So it's really just log 2 to the 12. So log 8x equals log 2 to the 12. But 8x is 2 to the 3x, so 2 to the 3x equals 2 to the 12. So x is 4. Expressed in simplest form, this is a 3-pointer? That doesn't even look bad. Okay. So it's x plus... They did something like this a few years ago. X plus x to the negative 1, that to the negative 1, and this to negative 1. Negative 1 just means take the reciprocal of it. Okay. The inside is 1 over x, so it's x plus 1 over x to the negative 1, that to the negative 1. So this is x plus x squared plus 1 over x to the negative 1 to the negative... Oh my gosh. That's crazy. They actually did this? So x plus... Well, then you take the reciprocal, so it's x over x squared plus 1. And then that to negative 1. So then it becomes x cubed plus x over x squared plus 1 to the negative 1. So then it's x cubed plus 2x over x squared plus 1 to the negative 1. So that's just x squared plus 1 over x cubed plus 2x. And you can't simplify that anymore. Because even if you factor out the x cubed plus 2x, you're going to get x squared plus 2, not plus 1. So it's x squared plus 1 over x cubed plus 2x. Done. More than 6 minutes to go on that one. Number 1's actually the hardest one, in my opinion, for this round. The greatest in... Yeah, negative 3x plus 6 minus x squared plus 3x less than negative x squared minus 2x minus 8. Why are the problems like so much easier now than they were? So 6 is less than negative 2x minus 8. A lot of stuff cancels. A lot of stuff cancels out. Yeah, so 6 is less than negative 2x minus 8. 14 is less than negative 2x. I don't like this problem. So wait, negative 8. What would negative 8 give? Negative 3. Negative 8 minus 2 is negative 10. So it's 30 minus... But it's really plus 8 times negative 8 minus 3, negative 11, is less than negative x squared, so it's negative 64 minus 2x plus 16 minus 8. Negative 88 plus 30, so negative 58 is less than negative 48 minus 8. Negative 58 is less than negative 56. That's awesome. But if we check negative 7, then it's not going to work. You get negative 3 times negative 9. So that's 27. Minus x, so it's really plus 7. And then x minus 3 is negative 10. Is less than negative x squared, so negative 49 minus... Really, it's 2 times 7, so plus 14 minus 8. Negative 70 plus 27 is negative 43, I think, is less than negative 49, so negative 35. Oh, that's actually going to be equal. Oh, wait, we saw that. It's equal. Negative 43, but again, you don't include it, so negative 7 doesn't work. So the greatest one is negative 8. And then negative 9, negative 10, whatever. So negative 8 is the answer to that one. The second one, I just want to make sure it actually works. Log 8 to the 4th. So 4 log 8 over log 2 equals 12. Log 8 is 3 log 2, so 12 log 2 over log 2 is 12. That's such an easy problem. And the third one is just a bash. Like, is that even Algebra 2? It's more just figuring out how to common denominator all this gargled stuff. I'm gonna do that one again, because I'm not convinced this is right. X plus 1 over x, and that's to the negative 1 power. And then you take the whole thing to the negative 1 power. X plus x squared plus 1 over x to the negative 1. That's a negative 1. So x plus x over x squared plus 1, negative 1. Like, I guarantee the question writer just, like, put x and negative 1s over and over, and it's like, what will happen there? X plus x over x squared. So yeah, it's x cubed plus x plus. It's not, if they put minus, the problem would have been so much nicer. To the x squared plus 1 to negative 1. Yeah, so it's x squared plus 1 over x cubed plus 2x. That's the answer. It has to be. We're done. And I'll just put on this sheet round 4. Negative 8, 4, and x squared plus 1 over x cubed plus 2x. I know for a fact on the acceptable answers form that they don't care if you factor it now. I know, like, when they had a problem very, very similar to this one, I think it was Meet 3 2018, and you had to actually factor it, I think. If you left it in expanded form, they marked it wrong, even though it couldn't be simplified. So, oh well. Round 5 time. I think we got a perfect so far. I don't know. Round 5. If there's a conic section problem, I am so screwed because I don't remember anything for conics. But let's go. 3, 2, 1, go. I've seen this one. I'm pretty sure it's 1/3. Lines A, B, and C, D are parallel. What is the value of x? Oh, don't they have to, like, add up to it? I swear, I've seen this one before. I've low-key seen this problem before. Yeah, so you have, like, a little thing. But if you extend the line, you get parallel lines. So 40. This becomes 40. X plus 70. And this is 2x plus 25. So this is really 110 minus x, because it's 180 minus x minus 70. So 110 minus x, and then it's 110 minus x plus 40 plus 2x plus 25 is 180. So this is 150, 175. So 175 plus x is 180. X is equal to 5. Wow. Okay, 5. 5 degrees. There's no trig. I'm pretty sure you just add them up and it has to equal the middle one. If n factorial ends in exactly 6 consecutive zeros, n is prime, what is the value of n? 25. It's 25, because if you have to use Legender's formula, which states that basically for every multiple of 5, you get an extra 0. So you get 5. Oh no, it's 6. Oh, no, it's 25, because if you get 5 factorial, you get 5 times 4 times 3 times 2 times 1, which ends in 1, 0. But then when you add another factor of 5, you're going to add another factor of 2, and then basically you're going to get another factor of 10, then you get 0. So you're just counting the number of factors of 5. So 5 factorial, then you get 10 factorial, 15 factorial, 20 factorial, so that's 4 zeros. Then you get 25 factorial, where you actually get 2 more zeros, because you have more factors of 2s than 5, so we don't have to worry really about the 2s. But in 5 factorial, you get 5 times 5, so that's 2 extra zeros. So then it's 25. Oh, but and prime? Oh, okay, so we just take the least prime greater than 25. 26, 27, 28, 29. It's 29. 29. And the 3-pointer, the line M y equals mx plus 1 intersects this was in, I think, Western Massachusetts Math League. I swear to God. I swear. And I got this one right. I'm pretty sure. I think it's like 1/3. But I know how you do this. Y equals mx plus 1. You just sub in mx plus 1, so it's x squared plus 4 mx plus 1 squared equals 1. And it intersects it exactly once. So x squared plus 4 times m squared x squared plus 2mx plus 1 equals 1. And then you expand it. So x squared plus 4 m squared x squared plus 8mx plus 4 equals 1. X squared plus 4m squared x squared plus 8mx plus 3 equals 0. And basically, if it intersects once, basically, if you think of a quadratic, because this is what we have, a quadratic, the discriminant is going to equal 0. So you just find the discriminant instead equals 0. So this is really 1 plus 4m squared x squared plus 8mx plus 3 equals 0. So discriminant is 0. So e squared, so 64m squared minus 4ac equals 0. 64m squared minus 12. 1 plus 4m squared equals 0. 64m squared minus 12 minus 48m squared is 0. So 16m squared is equal to 12. M squared is equal to 12 over 16, which is then 6/8, 3/4. It's 3/4. Because we could solve for m, but then you have to square it at the end, and m squared equals 3 over 4. Done. Done that one in 4 minutes, 37 seconds. I hope I got a 6 on this one, because this was actually a really tricky miscellaneous, I think. They always put number theory. They always put a dumb conics, but this isn't really conics, it's more algebra. You don't have to know anything about ellipses for that one. But yeah, parallel, you just add up the angles, and then you set equal to. Again, I'll put all of these files that I'm writing my work on the description of this video, so hopefully you'll be able to get some more insight, because if I were to write it on the computer, it would take forever. If you've seen my previous state playoffs video, you would see that it takes forever. So yeah, it's 3/4. I guarantee you everyone got that one wrong. That is a really tricky problem if you don't know what you're doing. 40, yeah, so it's 5. So 35 plus 40, 75, good. N factorial, 6 consecutive zeros, because think about it. 1 factorial is 1, 2 factorial is 4, but if you end in 0, you're going to have a multiple of 10. Like 10 times 10 is going to end in 2 zeros, because you just place the zeros at the end of the number. And if you end in 6, well, really, you're having 6 factors of 10. But how do we get factors of 10? Because a factorial is you go 1 times 2 times 3 times 4 times 5, all the way to whatever n is. So we want 6 factors of 5, and you get each factor of 5 every 5. 5, you get a factor of 5. 10, you get a factor of 5. 15, you get a factor of 5. 20, you get a factor of 5. 25, you get a factor of 5. You use Legender's formula. Legender was a mathematician, as you know, who actually created a formula using the least integer function. Or no, greatest integer function. So you take whatever you have the integer of and you round it down. So basically what you end up doing is you take a number, we'll say 29, and then you divide it by each successive power of 5. So you get the least integer function of 29 over 5, and then you add it to the least integer of 29 over 25, and then you'd go 125, 625, whatever. You don't use 2 because, well, we're going to find way more factors of 2. We want the least amount of 5s, because we want to find how many factors of 10 there are, and we need a certain amount of 5s. We're going to look at the one which has the least. I don't really know how else to explain that. But again, the smaller number, you have to take the smaller the numbers. Like if I have 5 red candies, 8 blue candies, and I want to make a mixture of red and blue candies, and that mixture counts as exactly 1 of each, well, how many mixtures can I make? You can't make more than 5 because that's all the red candies you have. You're taking the lower of the 2. Same here. You're going to have much less factors of 5. You're going to have a factor or 2 every other number, but you're going to have a multiple of 5 every 5th number. And in fact, you're going to get more multiples of 2 even quicker because you're going to have more powers of 2. Every multiple of 4 gives another power of 2. Every multiple of 8 gives another one, and every 16 So that's why you have to consider this. So the least integer 29/5 would be 5, and then you add it to this, which is 1 and 6. So this works. Again, if you take any number from 26 to 29 and you do it, actually you could do it to 25, and then 25 to 29 over 5. So you use Legender's formula. I'll just write it here. Legender's formula. This is not a known formula for Rimmel at all. But this is a really helpful tool. It's if you've ever seen a problem where it's like find the least n such that, I don't know, 7 to the k ends in exactly 924 zeros. I'm just making up numbers. Yeah, that's how you would do it. So I think that's right for 2. I'm actually gonna write round 6 on my, or no, it's round 5, not 6. I'm thinking of playoffs. 1, 2, 3. 1 was 5. 2 was 29. And 3 was 3/4. That third one's interesting. So I'll make sure I didn't make a mistake anywhere. I know what that ellipse would look like if you were to like graph it. It's basically like an oval for those that don't know. M squared x squared plus 2mx plus 1 equals 1. X squared plus 4m squared x squared plus 8mx, good, plus 4 equals 1. X squared plus 4m squared x squared plus 8mx plus 4 equals 1. So then it's becoming plus 3. Good. I swear that's from a past. That's definitely from like a past meet for a different competition. 3/4. It's gotta be 3/4. Okay, done. All right. Team. I'm giving myself 20 minutes. I probably won't need it all, obviously. Well, actually, I don't know. Usually teams are a little tougher. But team, again, you usually do it as a team. That's why you only get 10 minutes instead of like 20. So I gotta find the pencils. I had like a 5 on my bed. There we go. All right, team round. There's 5 problems coming up, unless the format changed. Ready, set, and go. Oh. 40. One's 40. They copied that from a past state playoff. I know for a fact. But instead of Brianna, they put P. I remember exactly. You just do Euler's totem function of 100 and you get 25. And if Euler's totem functions basically, well, let's take all the numbers and how many of them don't have like a number prime? It's hard to explain. Definitely 20, definitely 40. I know that for a fact. And it's Euler's of prime factorization of 100. So it's 2 squared times 5 squared. So then it's Euler's of 2 squared times 5 squared, or times Euler's of 5 squared. Use phi, or phi, I don't know how you pronounce it. It's a Greek symbol. Yeah. Okay, definitely 40. I know that one for a fact. 2, consider the integers k is less than 10. They did this for like a state playoff. Or it did very similar. So wait, so really number 2 is k plus 6, and we want to find integer values. But oh, I know why they're tricking, because they never said it was a positive integer. They just said integral value. So we get 1 when k equals -5. Actually, we get 0 when k equals -6. So -6, yeah. 1 when k equals -5. Oh, you have to find the sum of the k's? Okay. You're gonna get 2 when k equals, well, really it's when the inside becomes 4. So 2 when k equals -2. 3 when k equals 3, because 3 plus 6 is 9, root 9 is 3. Can I get, oh, okay. You can't use 10, because 10, 13, 15, 16, yeah. So we want the sum of -6 plus 5, -5. So -6 minus 5 minus 2 plus 3. So -11 minus 2, -13, so it's -10. The width of the rectangle is increased by 60%. By what percent must its length be reduced? This is, if you've ever heard of the AMCs, they use this problem a lot. The width of a rectangle is increased by 60%. So, let's say the width, let's just say it's 100. This becomes 160. And then what percent must the length be reduced? So it's 160x to 100. So x is equal to 100 over 160, so 10 over 16, 5 over 8. Wait, that's not right. 67.5%? Oh, wait, that might not be right. The width is in... Okay, wait, that might not be right. I might have to draw this out. Oh, wait, I didn't put it on the 20 minutes. Oopsies. So I will just change that right now. I'll keep the time that I had left. So 16 minutes, 35 seconds. Go. All right. The width of a rectangle is 60%. Okay, so let's have length and width. Area is length times width. Now we have width plus, or no, wait. If you're adding 60%, it's really going to be 8 fifths width. And then you're going to have x times L. So 8 fifths L width times x equals A. We know A is LW, so this is really going to cancel. So 8 fifths x equals 1, x equals 5/8. Yeah, so it's 67.5. Because it, or, no, it's not 67, 62, I think. It's 5, I'm thinking of 12.5. I'm really dumb. I'm actually going to do the division now. 48, 2, bring the 0 down. Yeah. It's 625, so 62.5%. Okay. For what value is it true that 3n plus... Basically, they're asking for some of the first n integers is 253. So it's just n times n plus 1 over 2 is 253. N times n plus 1 equals 406. I think it's 22 and 23. No. 18, 19, 19, 20. Oh, it's 506, not 406. Wow. Yeah, it's 22 and 23, I think. 6, 6, 0, 4, 4, 6, 0, 506. Yeah. So it's 22. It's just 22. Okay. And number 5, in the figure below, arcs CE and BD measure 80 and 20 respectively. AB, BC, AD measure 480 and 3. Determine the area of ABE. Ooh. Oh, I know what they're... Oh, no. You have to use Heron's formula? Oh, wait, no, you don't. That's actually a trick. That's actually a trick question right there. So basically, you have a circle. That's a horrible circle. You'll see what I mean if you actually look at the, So then you go, you make, this is a secant. You use power of the point, so 8, 4, 3. You want to find DE. I'll actually label it A, B, C, D, E. This is 80. This is 20. So what you end up doing is you take far arc minus near arc over 2. I think that's the formula. I remember doing a problem like this last year and I got it wrong. Or it was a team, so thank goodness it didn't actually count for my... So yeah, it's 80 minus 20 over 2, so that's 30 degrees. That actually works out nicely, because then that's the angle of CAE, 30 degrees. And then we have to use power of the point to find DE, so if we call DE x, 3 times 3 plus x equals 4 times 4 plus 8. So 9 plus 3x equals 16. Well, actually, no, it's just 12 plus, or no, well, yeah, it's just 12 times 4, so 48. 3x equals 39, x is 13. And we want to find ABE. Oh, okay. So then you just use the trig formula 1/2 AB sine C. You basically take the sine or trig function, the sine of the what's the word? Included angle. Basically the angle that's between the two sides that you're considering. So you take 1/2 of the two sides, so that you take AB, which is 4, AE, which is 16, and then you find sine 30 degrees. So then you get 32 times sine 30. Well, sine 30 is just 1/2, so 16. Done. But one is definitely from a state playoff. I know for a fact it is. You know what? I'm done. So I'm actually going to actually find I have a lot of playoff ones. I don't know which year it is though. Because I actually keep all the playoffs and actually all the questions on here. So I think it was 13 to 14. It was one of these, but it definitely was one of them. Was it this one? Yep, right here. He rewrites the numbers as a frac. I'm actually going to, if possible, do a side-by-side comparison. Oh, there's the answers. I don't want the answers. Yeah. This one, number 1, also came up last year. Number 3 also came up, if you can see it. Just 5 distinct factors. Me, literally, like, no one got this one except for me and, like, a few others. This one, yeah. It's exactly on the board. That's the only difference. Oh! Wait, I got trolled so hard. I got trolled so hard. It's not 100, it's 25. No. Oh, shoot. Okay. I actually have to consider that then. If Zoom lets me. Okay. I need to now. Oh, I messed it up. It's not 40. It would be 40 if it were 100. I think it's 10 then. Denominator 25 just means that it has a 5 times 5 in the denominator. So basically, how many numbers are relatively prime to 25? Well, I think it's for every 10, there's exactly 4 for 100. I think for every 40 have 100. I know that. How many of them are prime? Oh, I think it's like 30 something. I don't know. Well, you're gonna have 125, 225, 325, 425, 6, 7, 8, 9, 10. No, not 10. 11. This is just a bash at this at a time. 14, 16, 17, 18, 19, 21, 22, 23, 24. I got carried away there. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's 20. It's exactly half. Okay. Good thing I caught that. But yeah, it's not they just changed 100 to 25. 100 just means you would consider with 2 and 2 more. And that's definitely 40. I remember that. And you don't consider 25 first off because it's not a decimal. It's exactly 1, and second off, it's not in the interval from 0.01 to 0.99 inclusive. I think I'm done. We're gonna grade this actually. Yeah, we're done. Stop. We're gonna grade this and see how we did. Get a pen so I can grade this. I have no idea how I did. I think I got it perfect, but you never know. I might have gotten some things wrong. Let's just see. 79, 3, 325. Good. That's a 6. 250, 9, 4, 7. It's another 6. 49, 50, 2,880. It's another 6. -8, 4, and that. Yeah. Yeah, see, they let you. I told you. 6. 5, 29 and 3/4. Another 6. Did I get a perfect? 20, 10. No, I got that one wrong. It's the only one I got wrong in the entire thing. Got an 8. Okay, so we're gonna look at that one. Oh, I know why. I should have allowed more time because what happens is the question was asking, um, what percent must it be reduced? So for adding 62, you're really reducing by 30. Oh my, what did they do there? Yep, 8 fits. It's 3/8. Oh no. Yeah, see, you need a trig, but you don't use trig in the first. Well, actually, oh, you could. Oh my gosh. Jeez, I want to see their solutions. Were they actually similar? I only got one wrong. Yeah, that's obvious, easy. This was. Oh my, that's crazy. That looks like it's from some competition. Not gonna lie. Yeah. Oh my. Yeah, they did it exactly how I did every single one. Yeah, or you could just use that. 3 was just a bash. There wasn't like a nice way to even do that. Nonetheless, I got an 18 because I would have done Geo, Algebra II, and Miscellaneous, because that's what I have done basically every single time last year when those were the options. Oh, yeah, yep, that's what I did. So they did the exact same thing that I did. Who the heck does that? I love how they put the date as December 7th to 11th, honestly. That's actually pretty funny. All right, so that's gonna wrap it up. I hope you guys enjoyed. Let me know if you like it. Whenever I get meet 1, I'll do that. I'll do meet 3 and 4 possible, but I got college. This isn't my priority. I just happen to have a lot of free time on my hands. But again, this is me after I was the second top in Rhode Island. But hey, as you saw here, I actually regained a lot of my mathematical abilities. I didn't forget. So this is actually pretty fun. For me. So, hey, let me know if you like it. And peace. I'll see you next time.